Now coming to new energy technologies, we can see about the fluidized bed technology or pressurized fluidized bed technology that is considered as the major development in the field of coal-based power plants. So it's being used for enhancing the performance or increasing the combustion rate of the coal inside the power plant. Before going to fluidized bed technology, you have to know what do you mean by fluidization. Fluidization is a principle of fluidized bed technology and can be defined as a process wherein a granular material is converted from a static solid-like state to dynamic fluid-like state. The static solid-like state to dynamic fluid-like state is achieved through passing a fluid up through the granular material. The fluid might be liquid or gas at high pressure. Now look at the figure. So here, when a gas of velocity, a certain velocity is introduced through the bottom of the bed, and the bed or distributor, consider the distributor. So the distributor, above the distributor, you will be having solid particles. So what happens when the gas is allowed to pass through the distributor? The gas will try to escape through the empty spaces between the particles. But with increasing the velocity of the gas, what will happen? The particles tend to get suspended on the gas stream or fluidized. When the gas velocity is further increased, the bed becomes highly turbulent and rapid mixing of the particles takes place at this stage, and the solid particles will attain a pseudo fluid state. When the solid particles in the fluidized bed are preheated to the ignition temperature of the fuel, it will burn, imparting heat to the bed material. Okay, so this is what happens in a fluidized bed technology, where you will be having coal and limestone at the bed, and you will be providing gas at higher velocity, and at the same time your furnace will be maintained at a higher temperature, so automatically ignition will take place. And since the limestone and coal will be getting rapidly mixed, the combustion rate also will be higher. Okay, so where is this particular technology used? What's the applications? The main application is fluids or fluidized solids can be easily transferred between the reactors, and there will be an intense mixing within a fluidized bed, which means the temperature you attain will be uniform. There is an excellent heat transfer between the fluidized bed and heat exchangers immersed in the bed. To understand fluidization, you can just go through this figure. So consider a chamber. The chamber is having a bed, and this bed is having small pores through which the gas will come inside the chamber. And consider the bed is loaded with solid particles, and imagine these solid particles as plastic beads. So if you're providing a gas velocity, on the first case, if the gas velocity is small, very small, the gas will try to escape through the sides or the spaces between the beads. And with increasing gas velocity, a bubble will be created on nearby the pore, and a square nose will be created. And once the gas velocity is getting very higher, a regime or a turbulence will be created. And next, fast fluidization regime, and next part is your pneumatic transport. So at this part, what happens means the solid particles will be totally mixed inside the chamber. Okay, so what happens means a highly turbulent turbulence will be there, and the rapid mixing of the particles will be taking place at the last stage.
Fluidized Fluidized Bed Combustion or FBC. It's a combustion technology used to burn solid fuels. So solid fuels means mainly coal. Okay. So you'll be having a bed above which solid particles will be settled, which will be fluidized with the help of pressurized liquid or gas, mainly fluid. And this fluid will be passed through the medium, which makes or causes the solid particles to behave like fluids under certain conditions. And here what happens means the solid particles, the state of solid particle will be transformed from static to dynamic in fluidization. It can be classified into two types: bubbling fluidized bed combustion and circulating fluidized bed combustion. Bubbling FBC or bubbling fluidized bed combustion is used for fuels with lower heating values. Example, rice husk, sawdust, etc. While circulating fluidized bed combustion is mainly used for fuels with high heating values, coal, petcoke, etc. And the velocity of air, which will lead to the fluidization, is mainly depending on parameters such as the size of the fuel particles, so the size of the solid fuel or coal, and then the density of the air fuel mixture. Construction and working of a fluidized bed combustion system. So in the case of fluidized bed combustion system, the main part is your fluidized furnace. The fluidized furnace will be having a bed, a furnace bed, which will be having air distributor. So above the furnace bed, the coal or the solid fuel will be served. Again, inside the fluidized furnace, you will be having evaporator tubes or water tubes of the boiler. What's the purpose of a water tube? To convert the water to steam. To feed your solid fuels, you will be having hoppers. In the case of fluidized furnace, fluidized bed combustion system, you will be having coal and limestone, which will be fed through a hopper into a mixer, where the coal and limestone will be mixed and will be fed through a feeding system, which may be a conveyor system or a screw, onto the bed of the fluidized furnace. And apart from the fluidized chamber, you will be having a dust collector. The purpose of dust collector is to collect the dust or fly ash and separate the flue gas from the fly ash and send the flue gas to the air preheater. The purpose of air preheater is to preheat the intake air, which will be sent to the fluidized furnace. Now you can see through the figure that a blower will be there, which will take the air and which will pass through the air preheater, which will be preheated and will be sent to the fluidized furnace as fluidizing air. The dust collector collects the fly ash, which will be sent to the cement factories, or which will be recycled for fluidizing furnace. The recycle in the sense, if you are having the fly ash with coal presence, it will be again used for burning. So the main parts is his hoppers, mixer, feeding system, fluidized furnace, evaporator tubes, dust collector, air preheater, and blower. Now coming to working. How does a fluidized bed combustion system works? So a fluidized furnace has an enclosed space with a base having opening to admit air. Crushed coal, ash, and limestone is mixed in the bed furnace, and high velocity combustion air is then passed through the bed, entering from the furnace bottom. Okay, so with the steady increase in the velocity of the air, a stage will be reached when the pressure drop across the bed becomes equal to the weight per unit cross section of the bed, and this particular critical velocity is called as minimum fluidizing velocity. So what do you mean by minimum fluidizing velocity? A stage where the pressure drop across the bed will be equal to weight per unit cross section of the bed. With further increase in velocity of air, the bed will begin to expand and allow passage of additional air in the form of bubbles. when the air velocity becomes 3 to 5 times the critical velocity. The bed resembles to that of violently boiling liquid. The evaporator tubes of the boiler are directly immersed in the fluidized bed, and the tubes being in direct contact with the burning coal particles produce very high heat transfer rate. So in this figure you can see two set of tubes, one directly in contact with the bed and other one on the top part. Okay, so what happens when getting fluidized? So you will be having a fluidized bed all over the chamber, and now the two tubes will be in contact with the solid fuel, which will increase the heat transfer rate. Because of this increased heat transfer rate, the unit size is reduced to great extent and enhances the combustion rate with very high efficiency. Advantages and disadvantages of fluidized bed combustion system. So the main advantages are fluidized bed combustion system enhances the thermal efficiency. It's having an easy ash removal system, so which can be made for or which can be used for making cement. Short commissioning and erection period, fully automated, and thus ensures safe operation at extreme temperature. Efficient operation at temperature down to 150 degrees Celsius. Reduce coal crushing or pulverized coal is not necessary here. The system can respond rapidly to changes in load demand. The operation of fluidized bed furnace at lower temperature helps in reducing air pollution. NOx emissions are inherently low. Slagging and falling are reduced. Fuel flexibility means you can burn variety of fuels. Now coming to its disadvantages. The fan power has to be maintained at considerably high value. The intake or the air intaking fan power has to be maintained at a considerably high level. Air has to be supplied continuously at very high pressure for supporting the bed. The operating cost of the auxiliary units increases.